Hello friends, my topic is electron concentration in the conduction band. Before going to my topic, we must know about the conduction band by using the energy band diagram. Here is the energy band diagram in which always the lower band is known as the valence band and the upper band is known as the conduction band. In the middle of these two bands, there is a Fermi energy level and the gap between them is known as the energy gap. Now let's know the process. One covalent bond breaks at the valence band, then it forms hole in the valence band and the electron move towards the conduction band and the electrons are concentrated in the conduction band. Now we have to derive an equation to know the concentration of electron in the conduction band, especially in intrinsic semiconductor. In the case of intrinsic semiconductor, the number of holes in valence band is equal to the number of electrons in the conduction band. Now the electrons are present in the conduction band. They behave as a free particles with an effective mass Me. The number of conduction electrons are measured per cubic meter whose energy lie between E and E plus dE is given by dNc is equal to N of E into F of E dE, where N of E is the density of states at the bottom of the conduction band. First we have to measure the concentration of electrons per cubic meter, then by integrating it we can know the total concentration of the electron. Here the density of states equation is given by N of E is equal to 4 pi by h cube into 2me to the power of 3 by 2 into E minus Ec to the power of 1 by 2, which is known as equation 1. And next, by using the Fermi-Dirac probability function, which specifies the function of all the states at energy E under the condition of thermal equilibrium, is given by f of E is equal to 1 by 1 plus e to the power of E minus Ef by kT, which is known as the equation 3, where K is the Boltzmann constant and T is the temperature in Kelvin. Ef is the Fermi energy level. Since the electrons in conduction band may have energies lying from minus infinity to eV, the concentration of electrons in the conduction band is given by the equation Nc is equal to integration of Ec to infinity N of E into F of E dE. By integrating the equation 1, we will get this equation. Now by substituting the values of N of E and F of E in equation 4, we get Nc is equal to integration of Ec to infinity 4 pi by h cube into 2me to the power of 3 by 2 into E minus Ec to the power of 1 by 2 into 1 by 1 plus e to the power of E minus Ef by kT. Here the 4 pi by h cube into 2me to the power of 3 by 2 is constant and it taken out of the integration. Now the next equation becomes Nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 integration Ec to infinity into E minus Ec to the power of 1 by 2 by 1 plus e to the power of E minus Ef by kT into dE. By referring the energy band figure, E is very much greater than Ec and E minus Ef very much greater than kT, and the 1 in the denominator is neglected. Then the equation reduces to Nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 integration of Ec to infinity E minus Ec to the power of 1 by 2. The denominator part is taken into numerator, that becomes e to the power of Ef minus E by kT into dE. Now by splitting the equation, e to the power of Ef minus E by kT is equal to e to the power of Ef minus Ec plus Ec minus E by kT. By using the math equation, e to the power of m plus 1 is equal to e to the power of m into e to the power of n. The equation is splitted and the next equation becomes Nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 and e to the power of Ef minus Ec by kT is constant, so it taken out of the integration, then into integration of Ec to infinity E minus Ec to the power of 1 by 2 into e to the power of Ec minus E by kT into dE, which is known as equation 6. By substituting E minus Ec by kT is equal to x in equation 6 and making it differentiation, dE is equal to kT into dx. Now these values are substituted in the equation 6, that becomes Nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 e to the power of Ef minus Ec by kT into integration of 0 to infinity. Here Ec becomes 0 because it is the bottom of the conduction band. No, there is no energy levels at the 0 Ec, so it is 0. into x to the power of 1 by 2 into kt to the power of 1 by 2 into e to the power of minus x into dx. Here kt to the power of 1 by 2 and kt becomes kt to the power of 3 by 2. It is constant, so it is taken out of the integration. Nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 into kt to the power of 3 by 2 e into e to the power of ef minus ec by kt, integration of 0 to infinity x to the power of 1 by 2 into e to the power of minus x dx. Here we have an integration equation, that is integration of 0 to infinity in x to the power of 1 by 2 e to the power of minus x into dx is equal to root pi by 2. This equation is substituted in the above equation, that becomes nc is equal to 4 pi by h cube into 2me to the power of 3 by 2 into kt to the power of 3 by 2 into e to the power of ef minus ec by kt into root pi by 2. By taking 2 as a common, that becomes nc is equal to n is equal to 2 into 2 pi me kt by h square to the power of 3 by 2 into e to the power of ef minus ec by kt. Here h square and whole to the power of 3 by 2, it will become h cube, hence it is taken inside. Finally, by knowing the values of effective mass and Fermi energy and energy level, we can find the electron concentration in the conduction band. Thank you.